are finding all the zeros not given a zero, right? So do you remember how to narrow it down to zeros to try? We use the possible rational zero theorem, and we took the divisors of the constant, so we took the divisors of the constant. Remember, we had to remember plus or minus, so it made it lower. Plus or minus 1, 2, 5, and 10, divided by the divisors of our leading coefficient, 1 and 2. So then that narrowed our possibilities down to 1, 2, 5, 10, and also 1/2 and 5/2. I don't think there was any other combination. Okay, and then there's a whole bunch of trial and error, right? And there is no way to narrow it down. It is just trial and error. So you guys tell me, what should I start with? 5? Deal. 5 it is. What am I looking for at the end of synthetic division?
0.
Okay. 3. Oh my goodness. Who did that? Who did it? Bam! I'm ready to give you some candy. That 0 makes us so happy because we know we picked the right one. And then, so if 5 is a 0, it means that x minus 5 is a factor. And what's this guy called? Depressed polynomial.
I found another one, but it doesn't matter.
All right, so now to find my other zeros. There are a couple ways we can do this. I learned yesterday that you guys do not like to factor using the rainbow method very well. You don't love it. So another thing you could do, could you use the quadratic formula here and solve for x and get your zeros that way? Should we try it that way? All right, I'm seeing some yeses. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So what is that? Negative 3 plus or minus the square root of 9 plus what? 16? So 25 over 4. Let's just move this over here. So that means I've got negative 3 plus or minus 5 over 4. Negative 3 plus 5 is 2. Divided by 4 is half. And negative 3 minus 5 is negative 8. Divided by 4 is negative 2. And what was the 0 I found before? 5. So if you don't like to factor, is that a great way to do it? All right, who would rather use the quadratic formula? I'm curious. So some of us are like, yeah, it's actually not a bad idea, and some of you would rather factor. Okay, so that kind of reminds us how to get pretty answers. Today we can also get irrational, and we're going to get complex solutions. So let me find one of each. Right, exact values, not decimal approximations. So I'm going to go ahead and figure that that's not going to be a pretty problem. Wow, and it's bigger. I'm raised to the 4th on that one. That doesn't reduce or factor down in any way, but at least they were nice to me. They picked a number that didn't have a lot of factors. They gave me a prime number, right?
On both.
Oh, how nice. That's so kind and considerate. So I have plus or minus 1 and 7 divided by plus or minus 1 and 3. So that narrows it down to 1 and 7 plus or minus 1/3 and 7/3. You guys would like me to start with -7/3, I'm assuming? Yes? No? No? Should we start with a 1 or a 7? I heard both. All right, show of hands. Who wants a 1? Who wants a 7? 7 wins. Positive or negative? Positive 7? Negative 7. Negative 7 wins. All right. Trial and error. 3, -26, 38. When you're doing this, always pay attention to if you need a 0 in that synthetic division. It gets me in trouble too. All right. -21, -47. That just got huge, didn't it?
1 word.
1 works?
Yeah.
So I'm assuming positive 7 doesn't work. 1? All right. 3, -23, -23, 15, 15, -7, -7. There's that 0 we're looking for. Okay. So we have x minus 1 times our depressed polynomial. 3x cubed minus 23x plus 15x, thank you, minus 7. Yuck! Let me erase my scratch work right here. I should double check, you guys. Will this factor by splitting it down the middle? Am I going to have a common factor? Should I check though? Would it be awesome if it did? But it doesn't. So I'm still stuck. I've got to continue down this road. Can't factor it. I don't know the zeros of this guy. I can't use the quadratic formula because it's a cubed. So guess what I have to do again? What's that?
I keep pulling those numbers.
I keep pulling those numbers down. Now, just because I used one doesn't mean it won't work again. Do you remember back to those lessons with multiplicity, where a factor can be a repeated factor, right? We might have something like x minus 1 squared or cubed. I don't know. So I have got to do the whole process again with that. What number should we try? Does anybody count another one for me by chance? Should we try 1 again just to see? 3, -23.
Wait, so even though it worked, it doesn't work?
Oh, it totally worked. Look, it totally worked and it gave me a depressed polynomial right here. That's a good question. But now to break that polynomial down, I've got to do it on that one again because it doesn't factor. I can't use the quadratic formula. So I have got to repeat the process for my depressed polynomial because I need to break it up too.
And you just use those same numbers?
Well, it's a good question. Look, it ended up, what are my divisors? What are my factors of 7? And then my leading coefficient is exactly the same too. What's that?
Usually you're supposed to go back through and do this.
It could, well, it won't open more. Let's just put it that way.
Also, we tried 7 before, right? Or
We
-7.
did try -7, so it's not going to work. So think, if it wasn't a factor of the original, could it be a factor of something that had been reduced? It can't. So those are still going to be our possibilities. So we know -7 won't work. 1 could work again, and we still have -1 and +7 to try. So I figure 1 is easy, so I'm willing to try it. It didn't work though, right?
It's
It's what?
7.
All right, you want me to try 7 then?
Yeah.
All right, let's make this a 7. 3, 21, -2, -14, 1, 7. Yes. Glad you're working ahead on that one. Okay, so I now have x minus 1 times, if 7 is a 0, what's my factor? X plus 7. And then I have my depressed polynomial of 3x squared minus 2x plus 1. Are there two numbers that multiply to be 3 that add to be -2? That multiply to be +3?
No.
There are not two numbers that exist. So in this case, I am actually forced to use the quadratic formula on that. Let's see what those zeros look like. X equals the opposite of b plus or minus the square root. B squared minus 4ac all over 2a. 2 plus or minus, what is that? 4 minus 12? What kind of zeros are we going to get here? Yeah, I'm going to get complex answers or imaginary solutions. So that's going to reduce to, how does 8 break down? 4 and 2, 2 and 2. So that reduces to 2i, right? Square root of 2 over 6. How does that reduce?
Yeah.
All divisible by 2. So let me go to a darker number here. Let's see. 1 plus or minus I square root of 2 over 3. Oh, look, they have a plus or minus button for me. That makes me so happy. So,
one of the zeros or
2 of the zeros.
that is 2 of the zeros right there. Yep, good question. So there is, and I only need to type it once because they were nice and gave that plus or minus. So there's 1, 2 of the zeros. And then what makes this 0? What makes this 0? Goodness gracious. So 1, 2, 3, 4. Was that a nightmare? A little bit? A little bit. So the irrational numbers, what's going to happen underneath that square root? You just wouldn't have a negative number. You would have something that didn't require to pull out an I. In fact, they might be nice and have something that's like just the square root of 23 and you get to leave it like that. Should we do another one? Or you want one more? That was like forever because we had to do it twice. Let's see.
It's a good thing you can clear the board by doing that.
Yeah. Has at least one rational zero. All right, they're giving us nice, pretty prime numbers again. All my divisors of the constant, 1 and 2, divided by my factors of the leading coefficient, 1 and 5. So that takes it down to 1, 2, 1/5, and 2/5. All right. Should we start with the nice numbers? 1, 5, 6, -8, -1, -2. 5, 5, 11, 11, 3, 3, 2. Oh, look at that. All right. We have x minus 1 times our depressed polynomial. Now, in all honesty, when this is my scratch paper, I'll just start here again. Here's my depressed polynomial, right? Would those be the top numbers of my synthetic division now? All right. I might try one again just to see if it works. 5, 5, 16, 16, 19, 19. That one didn't work. Try -1. 5, -5, 6, -6, -3. That didn't work. What was my other nice number? 2? All right, 2. 5, 10, 21. How about we try a -2? All right. 5, -10, 1, -2, 1, -2. All right. So now this is continued to factor to x minus 1 times x plus 2. And what's my depressed polynomial? 5x squared plus 1x plus 1. I don't need that anymore. I don't need that anymore. What am I going to do on that last quadratic? I'm either going to factor it or I'm going to use the quadratic formula. I'm going to go ahead and say there aren't two numbers that multiply to be 5 and add to be 1. I can't think of any. So we'll use the quadratic formula. X equals the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. I hope I'm not killing you by doing some of those steps in my head. I think you guys do the same thing, don't you, on the quadratic formula? All right, -1 plus or minus, oh, another one, -19 over 10. Does that reduce? Lucky for us, right? Saves us a couple steps. How many answers is that right there? How many zeros? Okay, so there's 1, 2, because of plus or minus, and then I have 3, 4.
So you don't have a 12 imaginary.
I should have. We should rewrite it like this. Erase. We should say I square root of 19, right?
So you do have to write it back.
Yep, they'll want you to factor out that I for sure. Absolutely. Sarah's mud that time? All right, let's see where we go.